Good morning, everyone. Let's take the chapter further. We had already studied about the movement of rotation and revolution, its effect, then the position of the Earth with perihelion and aphelion positions, and of course, then we studied about the combined effects of the inclination of the Earth's axis. Now we're going to start with the changing season, that is the major action of revolution, where the position of the earth changes with respect to the sun, and then different weather conditions and day and night conditions are present. So there's a diagram in your book which is given on page 27. They've shown you the four positions of the earth here: 1, 2, 3 and 4. Now these are two positions of the earth, that is the summer solstice and the winter solstice. Now if you pay attention, in this diagram the sun is in the center. Here the south pole is facing the sun, and in this particular position north pole is facing the sun. So we're going to study about these two positions in comparison and see what are the changes which happen from one to another. Now, this is the position of the winter solstice as it is shown in your book. This position happens on 22nd of December, and this position happens on 21st of June. We call this as the summer solstice and this position as the winter solstice. Now if you see, the sun I have made in the center. The north pole is facing away from the sun in this particular diagram, and in this particular diagram the north pole is facing the sun. So what are the difference between the two and how the changes happen? Now here, equator, which is receiving direct rays of the sun, this is the line of equator, if you can see, 0 degree. So at equator the sun rays are vertical, and therefore the equator has 12 hours of day and 12 hours of night. In the southern hemisphere, that is 23.5 degrees south, that is Tropic of Capricorn, the sun rays are vertical, and therefore we have longer days in the southern hemisphere and shorter nights. When the days would be longer, obviously the amount of time left for the nights will be less, and therefore longer days and shorter nights in the southern hemisphere, because southern hemisphere is facing the sun. Northern hemisphere will have winters because it is not facing the sun, and southern hemisphere will have summers because it is facing the sun, and the sun rays are falling vertical at Tropic of Capricorn. The exact opposite happens on 21st of June here. Here also, though the sun equator has 12 hours of day and 12 hours of night, but the sun rays are falling vertical on Tropic of Cancer, that is 23.5 degree north. And since it is falling on Tropic of Cancer, therefore we have longer days in northern hemisphere and shorter nights. Northern hemisphere will have summers, and southern hemisphere, which is facing away from the sun, will have winters, and the sun rays will fall vertical on Tropic of Cancer. This is a comparison between the two winter solstice and summer solstice, which is happening on 22nd of December and 21st of June respectively. Then if you come back to that same diagram here, there are two more positions which have been given in your diagram. Now if you see, in both the cases, neither the north pole is facing the sun nor the south pole is facing the sun. It is an intermediate position, and this intermediate position is called as equinox. This is the spring equinox and this is the autumn equinox. Now the dates for the two are autumn equinox 23rd of September, and spring, which is also called as the vernal equinox, 21st of March. Now these two times the sun rays are vertical at equator, and we have 12 hours of day and 12 hours of night throughout the world. Now this position, if you see again in your diagram, the sun rays are falling vertical at equator. Both the hemispheres are neither facing the sun nor away from the sun. They've given you some important dates to remember here, the same which we've already done. June 21st, which is called as the summer solstice, longer days and shorter nights in northern hemisphere. Then comes the equinox. Equinox means equal night or equal day. September 23rd, autumn equinox, equal day, equal night in both the hemispheres. December 22nd, winter solstice, longer days, shorter nights in southern hemisphere. And March 21st, vernal equinox, equal days and equal nights in both the hemispheres. Now, There is one more phenomena which happens on 21st of June, which is called as the midnight sun. This midnight sun is experienced in the North Pole closer to Arctic Circle, because during summer solstice, that is 21st of June, the North Pole is inclined towards the sun, and the region beyond the Arctic Circle experiences 24 hours of day. If you look at this diagram again in your book, we are talking about this diagram. Beyond Arctic Circle, it is 24 hours of day, and therefore the places located here are able to see the sun very low at the horizon, especially in Norway at midnight. So imagine watching the sun very low at the horizon, that reddish sun at around 12 o'clock at midnight, and therefore it is called as the midnight sun. And of course, Norway is also called as the land of midnight sun, which you have heard about many a times over. So this phenomena is very pretty. People go and visit Norway during this time period to watch this phenomena live with their own eyes. Hearing it and looking at it is very, very different. You can go on YouTube, you'll be able to find the midnight sun phenomena of Norway. There will be plenty of videos there which you can have a look at after you have studied the entire chapter. Now we have three more terms which we need to discuss on page 31. This is twilight, dawn, and dusk. Now twilight is the transition period between day and night, or vice versa, that is between night and day. So that means when the sun sets and between setting of the sun and complete darkness, and just before the sunrise, that complete darkness, that time period is called as the twilight time, which is the transition period. Now in this transition period, we have two very, the sun is very low at the horizon just before the sunrise, or just after the sunset. That is the time when we call it as twilight. Then we have the dawn just before the sunrise. When the sun is just about to rise, we specifically call it as dawn. And just after the sun has set and the night has not occurred, that time period we call it as dusk. So these are the three terms which are generally used, because we don't see the abrupt change from day to night or vice versa. So there's a period of this diffused light which is known as twilight, and it is actually produced by the scattering of the particles, air molecules, and dust and water vapor, which are reflecting the rays of the sun back to the earth's surface. So that is the reason why all this is caused, and it has a different look at this time of the earth, at this time of the day. So earth looks very, very different. It looks that orangish, reddish tinge is given to the look of the earth, and therefore this name has been coined specifically to earmark this time period of transition just before the sunrise and just after the sunset. Now the chapter is over at this point. I have given you one more video earlier, and this is the second video of that chapter, that is chapter 3, motions of the earth. In the next session, I'll be giving you the written work. I would prefer that you do upload your written work on the Google Classroom. It will be very, very convenient for me to correct, and we can go further when the school reopens. Thank you.